today we are reviewing the properties of exponents, and I want to show you why each of these properties works the way that it does, because I think if you know why, it helps you to remember them. Also, please know that I will put the name of the property here, but I am never going to force you to memorize the names of the property. I'm not going to give you a matching problem on the test that says, match the name of the property with it. I'm not going to do that. Okay, we'll start with multiplication. In an exponent function expression, you've got a base and you've got an exponent. If I have something like a to the m, a is the base, m is the exponent. This means m factors of a are being multiplied. So here, 2 squared means that there are 2 factors of 2. It means 2 times 2. 2 to the 5th means that there are 5 factors of 2. If I have 2 factors of 2 multiplied with 5 factors of 2, how many 2's do we have there? 7. We have 7 factors of 2. 2 to the 7th means 7 factors of 2 are being multiplied together. A wonderful student in my class said, so can we just add 2 and 5? Yes, that's kind of the point. The property of powers, product of powers property says if you are multiplying with the same base, all you're really doing is adding those exponents together. So 2 to the 1st times 2 to the 6th is 2 to the 7th because 1 plus 6 is 7. Now, I do sometimes get the question, wouldn't it be 14 to the 7th because you have to multiply the 2's together? No. 2 to the 1st means 1 factor of 2. 2 to the 6th means 6 factors of 2. 2 to the 7th means that there are 7 factors of 2 being multiplied. So you don't actually multiply the bases together. All you're doing is adding those exponents. So now let's apply it to variables. A to the 3rd times a to the 6th. What would that become? A to the 9th. Lovely. All right. And we're actually going to do this a little bit out of order because I think it makes more sense for our brains. So we're going to skip down to number 9. When we were multiplying, we added the exponents. Now we're dividing. What do you think that means for the exponents? We're probably going to subtract. So you're guessing this is going to be 2 squared, right? Because 3 minus 1 is 2. Here's why. 2 to the 3rd means 3 factors of 2. 2 to the 1st means 1 factor of 2. The 1 factor of 2 on the bottom cancels out 1 factor of 2 on the top, and you're left with 2 factors of 2. So yes, the shortcut is you subtract the exponents. So 2 to the 5th divided by 2 squared would be 2 to the 3rd. A to the 6th divided by a squared would be a to the 4th. Easy peasy. All right, now let's look at parentheses. 2 squared, we already agreed that 2 squared means 2 times 2. This thing to the 3rd means that we're going to have 3 of these. We're going to have 2 factors of 2 3 times. How many 2's do you see written there? 6. Is there any way that we can take the numbers 2 and 3 and get 6? We multiply. So the power of a power property says that if you have parentheses in between those exponents, you are going to multiply the exponents together. 2 squared squared would be 2 to the 4th. How about a to the 3rd to the 4th? A to the 12th. Okay, this kind of continues if you have multiple factors inside those parentheses. So here I have 2b, that whole thing squared. That means 2 times b twice. How many factors of 2 do we have? And how many factors of b? 2. So that exponent is applied to all of the things that are being multiplied inside the parentheses. So ab to the 3rd is really a to the 3rd, b to the 3rd. Now, combining that last property with this property, what if we have a squared times b, the whole thing raised to the third. A to the sixth, b to the third. Okay. Okay, you all have heard of Pemdas, right? If you write Pemdas with 2 letters per line, it creates a visual that can help you remember the properties of exponents. When you see parentheses, you multiply your exponents. When you see multiplication, you add your exponents. When you see division, you subtract your exponents. So this is a visual way to kind of remember those simple properties of exponents that we just went over. Okay, now this is an extension of the parentheses property that we just learned. 3/4 squared. If you really want to see why this is, 3/4 squared means 3/4 times 3/4, which means that you have 2 factors of 3 on the top and 2 factors of 4 on the bottom. So really, it's the same thing. You apply that exponent to everything inside the parentheses. Now, this only works when you have multiplication and or division inside the parentheses. If we have addition or subtraction inside the parentheses, you can't just stick the exponent on there, but with multiplication and division, you can. So number 13, a over b to the third becomes a to the third over b to the third. A to the m over b to the m. 2 to the 0 means 1. Now, why is this? I'm actually skipping forward to number 15, but that's okay. Anything raised to the 0 power is 1. Anything to the 0 is 1. This is because the way that an exponent expression, the things that it represents, this means there are 0 factors of 2. You can always put a 1 in front of something. There's always 1 times whatever there. But if there are 0 factors of 2, that 2 doesn't exist, there's only the 1. So anything to the 0 power means there are no factors of that, which means it's just a 1. Okay, 2 to the first. We know 2 to the first. 2 to the first is 2. In your calculator, if you try 2 raised to the negative 1, you would get 0.5, which is the same as 1/2. Next, I'm going to do 2 squared. 2 squared is 4. And if I punch 2 to the negative 2 into my calculator, I get 0.25, which is 1/4. Is it interesting that 2 squared is 4 and 2 to the negative 2 is 1/4? 2 to the third is 8. Anyone want to take a guess what 2 to the negative 3 is? It is 1/8. And 2 to the fourth is 16. What do you suppose 2 to the negative fourth is? 1/16. I'm going to take this a little bit further. So 2 to the fourth, or 2 to the negative fourth, is the same as 1 over 2 to the fourth, which is 1/16. Negative exponents move. It actually causes the expression to take the reciprocal. So if you've got a to the negative m, that becomes 1 over a to the positive m. Now, likewise, if I had 1 over a to the negative n, what do you suppose would happen? It would become a to the positive n on the top. Negative exponents move. If there's a negative exponent in the numerator, that term will move to the denominator where the exponent will then be positive. If you've got a negative exponent in the denominator, it will move to the numerator where it will then have a positive exponent. So let's try something like x to the negative fourth over y to the negative third. What would that become? Y to the positive 3 over x to the positive 4. Going back to that 0 exponent property, 5 to the 0 is 1, 8 to the 0 is 1, and negative 3 to the 0 is 1. Okay. Now, if I asked you to memorize the names of the properties, we could do these problems step by step and write out the name of the property that we used. That's called a proof. We could write proofs. No, you don't want to write proofs? You sure? You positive? Oh, okay, we won't write proofs. Okay, the first one you can do on your own. 6 squared times 6 to the third. Do that one on your own, and then, yeah, do 18 on your own. Just like with Pemdas, anytime you see parentheses, you should really deal with those parentheses first. So in number 19, the first thing I'm going to do is 9 squared raised to the negative third. So we've got 9 to the 6th. 9 squared to the negative third, that's parentheses. So we multiply those, and that gives us 9 to the negative 6th. Then we have multiplication, so we would add those exponents and get 9 to the 0, which is 1. Okay, number 20. I've got 3 over 2 to the negative 1. I'll deal with that in a minute. I want to deal with these parentheses first. 1/2 squared means 1 squared over 2 squared. Okay, now you can evaluate 1 squared. 1 squared is just 1. So really on the top, all we have is 3. On the bottom, we have 2 to the negative 1 times 2 squared. We're multiplying those denominators together. What is negative 1 plus 2? 1. So we have 2 to the first, or just 2 on the bottom. Try number 21 and number 22 on your own. I think you can do those on your own. So give 21 and 22 a try on your own. So the first step is 3 to the negative 2, 5 to the negative 2, and then negative exponents move. So you end up with 5 squared over 3 squared. Technically, that would be 25 over 9, but I don't care about that step. I care about you using the properties more than evaluating. Number 22, there are at least 3 specific ways that you could do this problem. What I see is division. So I'm going to deal with the division first. Because there's division, I'm going to subtract my exponents. What is negative 5 minus a negative 3? That's negative 5 plus 3, that's negative 2. So this becomes 7 to the negative 2. I can't leave my answer with a negative exponent, so that becomes 1 over 7 squared. Now, some of you may have done, okay, well, this is 7 to the third over 7 to the fifth. Then I subtract and get 7 to the negative 2, and then it becomes 1 over 7 squared. So there's several different ways that you could go about getting from the beginning to the end of this problem. It depends on which property you decide to use first. Number 23. Again, anytime you see parentheses, you should deal with that problem first. So that becomes a squared over b to the 6th, because the 3 times the 2 is the 6. We still have a to the 4th, b to the 3rd over a squared b. Okay, in my numerators, I'm going to make a spot up here for this. There we go. In my numerators, we've got a to the 4th and a squared. A to the 4th and a squared becomes a to the 6th. And there's the b to the 3rd in there. In the denominators, we've got an a squared. B times b to the 6th would be b to the 7th. Once you get it to this point, now you're going to simplify vertically. So you've got a to the 6th over a squared. I'm going to delete these now. A to the 6th over a squared, you would subtract. 6 minus 2 is 4. B to the 3rd divided by b to the 7th. What is 3 minus 7? Negative 4, so you'd have b to the negative 4th, which would move to the bottom and be b to the 4th on the bottom. Another way to think about this, a squared cancels out 2 of the 6, leaving you with 4 on the top. b to the third cancels out 3 of the 7, leaving you with